The learning objectives for today are: solve exponential equations and inequalities using common logarithms, and evaluate logarithmic expressions using the change of base formula. Let's refresh our knowledge about logarithms. In an expression of log b m equals n, then b is called the base of the logarithm and n is called the exponent. When a logarithmic function has a base 10, we call it common logarithm. Also, when the base is not written, then it will mean the common logarithm with base 10. We can also say log 10x, which is the same as log x. We like to use the common logarithm because it is very easy to find it with a calculator. Well, first, if you have to find the value of the common logarithm, then first you need to press the log button, then you need to press the numbers what's inside the log function. Afterwards, of course, you need to press equal to find the value. Let's see two examples on how to use the calculator to evaluate each expression to the nearest 10,000. First of all, log 5. Remember, first we need to press the log button and then press 5 and then the equality sign. Then your calculator will write out this value. And remember, we need to round to the nearest 10,000, which means we need to keep 4 decimal places after the decimal point. This means we need to focus on the 5th decimal place, check whether if it's above or below 5. Since this is 7, it means I need to round up this 9 to 10. But I can't do that. I can only round up the next digit. So therefore my last 2 digits will be 90. Now we need to find the value of log 0.3. So again, you need to type the log button first, then type 0.3 and then press the equality sign. This is what we will see on the screen. And then we need to round it to the nearest 10,000, which is again, we need to keep the first 4 decimal places. And now this is your turn. Here are some questions for you to try. Now please pause the video and press play once you have your answers. And here are the answers for the previous questions. I hope you all remember the definition of the logarithms. So you would also know how to convert common logarithm to the exponent form. Well, if we have log x equals y, that means 10 to the power of y equals x. Therefore, log 1 equals 0, since 10 to the power of 0 is the exponent, which would give us 1. Log 10 equals 1, since 10 to the power of 1 is the exponent, which would give us 10. And log 10 to the power of m equals m, since 10 to the power of n would give me 10 to the power of n. So we can convert common logarithms if we want to solve it for a certain specific variable. Now let's take an example. The loudness L in decibels is L equals 10 times log I over m, where I is the intensity of sound and m is the minimum intensity of sound that is detectable by the human ear. Residents living several kilometers from a concert venue can hear the music at an intensity of 6 to 6.6 decibels. How many times the maximum intensity of sound detectable by human ear was the sound if m is defined to be 1. Now, given is that L equals 66.6 and m equals 1. Now let's see what are we looking for. Well, we're looking for the intensity, which was capital I. Let's see the solution step by step. We need to use this equation from the question, and then we will substitute each value. So L was 66.6 and M was 1. We're looking for I. Let's divide both sides by 10, and then we will get this simple equation 6.66 equals log I over 1. If I use the exponent form, I will get 10 to the power of 6.66 equals I over 1. Well, I over 1 is simply I, isn't it? So, if I type in this part, the left-hand side to the calculator, I will get this result on the screen. Let's have a look at the applications of the common logarithm. Well, they would be useful to solve exponential equations, for example, these two, or it would be also very useful to solve exponential inequalities, like these two. What is the idea? What are the steps? Well, first of all, we will need to take the logarithm of both sides. Let's see a few examples on this. Solve for x, round to the nearest thousands. This means we have to keep the first 3 digits after the decimal point. As you see, our first task is to solve this equation. And as I mentioned in the previous slides, we need to take the common logarithm of both sides. Now we need to use the power property of logarithms, which means this x will come down here to multiply log 6. Therefore, we simply need to divide by log 6. Here we go. And this is something we can easily type into our calculator. And our answer is 2.086. We can check our answer very easily. We simply need to insert 6 to the power of 2.086 into the calculator, and we get approximately 42. It's not exactly 42 on the calculator because this was only a rounding. But we see it is a correct answer, so therefore our x value was also correct. Here in part B, we have to solve an inequality. Our first step is the same. We need to take the common logarithm of both sides. Now we use the power property of logarithms. Here we go. And we need to expand the bracket on the right hand side. Now we need to move both the variable terms to be on the same side. Therefore, I will subtract x times log 6. Here we go. And now I notice that I have x in both terms. That's the common factor of these two terms. So I will factor the left-hand side. Here we go. Now it is very simple. We need to divide both sides with this expression in the bracket. Now we isolated x, and even though the right-hand side looks a little bit difficult, it is actually very simple. We can type it into the calculator and we will get a value. We get the value that x is greater than or equal to 4.419. And now it's your turn to try. Please pause the video and press play once you have your answers. It seems you're ready with your answers. So here are the solutions for you to check.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
The change of base formula. Now, what is the change of base formula and why would we need it? Well, sometimes we have to evaluate logarithmic expressions or solve logarithmic expressions, but the logarithms are not in the best form. Well, in these cases, we can simply use the change of base formula and get whichever base we would like to get. Let's see what it is. For all positive numbers a, b, and n, where a is not equal to 1 and b is also not equal to 1, then log an equals log bn over log ba. I hope you noticed that here we had a base of a, and on the right hand side we get the new base in the numerator and the denominator as well. Now let's see, the numerator's argument comes from the previous logarithm's argument, and the denominator's argument comes from the previous base of the logarithm. Now let's see this in use. Find out how much is log 3, 11. First of all, I hope you remember, we need to use the common logarithm. So on the top we will have to use the argument in the new log's argument, and the denominator will have number 3, so the base, as an argument. So therefore we would have log 11 over log 3. Here we go. And this is simple, we can type it in easily into our calculator. Let's see how much we get. It is 2.183. Now, this is your turn to try to solve the following questions. Please pause the video and press play once you have your answers. Now I believe you have finished, so let's see the answers. How did you do?